Hello GATE aspirants. Welcome to part 1 of GATE Atomic and Molecular Physics series. Question number 14. To detect trace amounts of gaseous species in a mixture of gases, the preferred probing tool is, now the gases are in trace amounts, so the required probing tool will be laser spectroscopy. Next question. A collection of N atoms is exposed to a strong resonant electromagnetic radiation with Ng atoms in ground state and Ne atoms in excited state such that Ng plus Ne is equal to N, that is total number. This collection of two-level atoms will have the following population distribution. Now this is a two-level system, and at population inversion this Ng will nearly be equal to Ne, and that will be equal to N by 2. So here option C is correct. Question number 16. Two states of an atom have definite parities. An electric dipole transition between these states is. Now it is electric dipole transition, that means parity will change. So parity changes, so they will be having opposite parities. So it will be allowed if the two states have opposite parities. Option C is correct. Next question. The spectrum of radiation emitted by a black body at a temperature 1000 Kelvin peaks in the region. Here temperature is 10 raised to 3 Kelvin, and we know by Wien's displacement law lambda mt is equal to B, where B is Wien's constant. So from here lambda m is equal to B by T, which is 0.2892 into 10 to the power minus 3 upon 10 to the power 3. So this will be 289 nanometer, and that will be IR, infrared, because 400 to 700 is visible and this is 289, that means it will be infrared. So option B is correct. Next question. The three principal moments of inertia of a methanol CH3OH molecule have the property Ix is equal to Iy is equal to I and Iz is not equal to I. The rotational energy eigenvalues are. Now the rotational energy is E is equal to, this can be written as J square by 2I, or if we have different values, here J is momentum, angular momentum, so this can be written as Jx square by 2Ix plus Jy square upon 2Iy plus Jz square upon 2Iz. Here Ix, Iy and Iz are moments of inertia along x, y and z axis. Here it is given that Ix is equal to I, y, and Iz is not equal to that. So here we can write this Ix will be Iy, so this we can take common. So this will be 1 upon 2I, and in bracket we have Jx square plus Jy square plus 1 upon 2Iz into Jz square. But we know J square is equal to Jx square plus Jy square plus Jz square. So here we can write J square minus Jz square. So E will be equal to 1 upon 2I, in bracket this will be J square minus Jz square plus 1 by 2Iz Jz square. We can take this Jz square terms common, so this will be 1 upon 2I J square plus 1 upon 2Iz, and this minus sign, minus 1 upon 2I into Jz square. Now we know J square is equal to Jj plus 1 h cross square. So this will be h cut square upon 2I into J plus 1 plus 1 upon 2Iz minus 1 upon 2I. Jz square is mj into h cross. So square is mj square upon h cut square. We can take this h cut square common, and then option A will be correct. Next question. Match the typical spectra of stable molecules with the corresponding wave number range. First is electronic spectra, rotational spectra, molecular dissociation. Now electronic spectra, it is in visible range. So this will be 10 to the power 5 to 10 to the power 6 per centimeter, which is equal to 10 to the power minus 7 meter to 10 to the power minus 8 meter. So this is in visible range. Then rotational spectra, it is in microwave range. So this will be 10 to the power 0 to 10 to the power 2 per centimeter. So that is 10 to the power minus 2 meter to 10 to the power minus 4 meter. And it is in microwave spectra. And molecular dissociation is this one. So 10 to the power 6 per centimeter and above, that is 10 to the power minus 8 meter and below. And that will be UV and gamma. So here option B is correct. 1, 2, 2, 3, 3, 1. Next question. CO2 molecule has the first few energy levels uniformly separated by approximately 2.5 milli-electron volt. So if this is ground state, then this will be first excited state, then we have second excited state, and so on. So the separation between those is 2.5 milli-electron volt for all. Now at a room temperature of 300 Kelvin, the ratio of the number of molecules in the fourth excited state to the number in the second excited state is above. So this is second excited state, then we have third excited state, and then fourth excited state. So fourth excited state is actually fifth state. So that means we have to calculate N5 upon N3. Fourth excited state to second excited state. And that will be equal to exponential minus of delta E by kT. So this will be equal to exponential of. So this is fourth state and this is second state. So the difference between these two means this one. So this is 2.5 plus 2.5. So that will be minus 5 milli-electron volt. Upon kT, this is temperature is 300 Kelvin. So that means kT will be 26 milli-electron volt. So upon 26 milli-electron volt, and this comes out to be 0.825. So here option C is correct. Next question. In the presence of a weak magnetic field, atomic hydrogen undergoes a transition 2p1/2 to 1s1/2 by emission of radiation. The number of distinct spectral lines that are observed in the resultant Zeeman spectrum is. So for here, we have for this case, we have to calculate first Landau factor G. Now G is 1 plus J plus 1 plus S plus 1 minus L plus 1 upon, it will be 2J plus 1. So this we will calculate for both the cases. We have this 2 p1/2 and we have 1s1/2. So that means for this L will be, it is p orbital, so L is 1 and S will be 0. Then S will be half and half. So J will be half. Here it is value is given. This J is half and this is half. Now these are values of L, J and S. We can substitute those here and then we will get value of G. So here L is 1, S is half. So if L is 1, then this will be, G will be 2/3. And if we put in this equation, if we put L is equal to 0 and S is half, J is half, then G will be 2. So these are values of G. Now we can calculate number of Zeeman levels. And that is equal to, that number is equal to 2J plus 1. And here J is half. So this will be 2 into half, that is 1 plus 1, 2. Here also 2. And value of mz will be, since there are two values and value of z is 1 by 2, so mz will be minus 1 by 2, 1 by 2, minus 1 by 2, 1 by 2. Now this transition is from P1 by 2 to S1 by 2. And this is D1 line. Now P half can be separated in two levels and this S half can be separated in two levels. So there will be 1, 2, 3 and 4 transitions. So these many transitions are possible. And this will be pi transitions, this will be sigma transitions, like that. So if delta mz is equal to plus minus 1, then that is sigma transition, that will be sigma line, and otherwise it will be pi line. So this D1 line, it splits into 4. So here option C is correct. And if it was given P3 by 2 to S1 by 2, then that would have been D2 line and it splits into 6 lines. Here answer is 4. Next, this spectral line corresponding to 2p1 by 2 mj half to 1s1 by 2 mj minus half is observed along the direction of the applied magnetic field. The emitted electromagnetic field is, here let us calculate delta mj, and delta mj is plus 1. So that means it gives sigma plus component. So it will be in the longitudinal observation, it will be sigma plus is left circularly polarized. So it will be option A. In longitudinal observation, sigma plus is left circularly polarized. So here option A is correct. And if it was sigma minus, then it would have been right circularly polarized. So these were all the questions from GATE 2010 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.